Energy and matter. Energy and matter characterize both physical and biological systems. This means that energy and matter can change forms but cannot be created or destroyed. Energy and matter are often cycled within a system, and different forms of matter and energy are able to interact. The surrounding environment must be considered when studying a system's energy and matter to examine flow into and out of the system. Scientists seek to study the flow and interactions of matter and energy, while engineers often seek to minimize inputs and maximize outputs of matter and energy relative to a given system. Energy is defined by physicists as the capacity to do work. Energy is found on our planet in a variety of forms, some of which are immediately useful to do work, while others requires a process of transformation. The sun is the primary energy source in our lives. Besides water, fossil fuels such as coal, petroleum products, water, and nuclear power plants are sources of energy. The growing energy needs. Energy has always been closely linked to man's economic growth and development. Present strategies for development that have focused on rapid economic growth have used energy utilization as an index of economic development. This index, however, does not take into account the long-term or ill effects on society of excessive energy utilization. For almost 200 years, coal was the primary energy source fueling the Industrial Revolution in the 19th century. At the close of the 20th century, oil accounted for 39% of the world's commercial energy consumption, followed by coal, which has 24%, and natural gas, which has 24%, while nuclear, which has 7%, and hydro or renewable, which has 6%, accounted for the rest. Industrialization, urbanization, and unbelievable rise in human settlements have multiplied the energy requirement by several times. Modern lifestyle and man's growing dependence on machines and equipment for his personal and professional work has added to the energy demand. Global oil demand continues to grow until 2040, mostly because of the lack of easy alternatives to oil in road freight, aviation, and petrochemicals, according to WEO 2016, which was published by International Energy Agency. There are renewable energy resources where environment can benefit. Renewable energy systems use resources that are constantly replaced and are usually less polluting. Examples include hydropower, solar, wind, and geothermal, or energy from the heat inside the earth. We also get renewable energy from burning trees and even garbage as fuel and processing other plants into biofuels. We will now discuss what is matters and cycles. The Earth's biogeochemical systems involve complex, dynamic processes that depend upon many factors. The three main factors upon which life on Earth depends are the wave flow of solar energy into the Earth's systems as radiant energy. It is used by plants for food production. As heat, it warms the planet and powers the weather system. Eventually, the energy is lost into space in the form of infrared radiation. Most of the energy needed to cycle matter through Earth's systems comes from the sun. The cycling of matter, because there are only finite amounts of nutrients available on the earth, they must be recycled in order to ensure the continued existence of living organisms. The force of gravity. This allows the earth to maintain the atmosphere encompassing its surface and provides the driving force for the downward movement of materials and processes involving the cycling of matter. These factors are critical components of the functioning of the Earth's systems, and their functions are necessarily interconnected. The main matter cycling systems involve important nutrients such as water, carbon, nitrogen, and phosphorus. Water cycle. The Earth is sometimes known as the water planet because over 70% of its surface is covered by water. The physical characteristics of water influence the way life on Earth exists. All living organisms require water for their continued existence. The water cycle or hydrologic cycle is composed of the interconnections between water, reservoir, and the environment and living organisms and the physical processes, example evaporation and condensation, involved in its transport between those reservoirs. The oceans contain about 97% of the total water on the planet, which leaves about 3% as fresh water. Most of the fresh water is locked up in glacial and cap ice or buried deep in the earth, where it is economically unfeasible to extract it. Carbon cycle. Carbon is the basic building block of all organic materials and therefore of living organisms. However, the vast majority of carbon resides as inorganic minerals in crustal rocks. The carbon cycle is actually comprised of several interconnected cycles. The overall effect is that carbon is constantly recycled in the dynamic processes taking place in the atmosphere. At the surface and in the crust of the earth, for example, the combustion of wood transfers. The carbon cycle is very important to the existence of life on earth. The daily maintenance of living organisms depends on the ready availability of different forms of carbon. Fossil fuels provide an important source of energy for humans, as well as the raw materials used for manufacturing plastics and other industrially important organic compounds. Nitrogen cycle. The element nitrogen is important to living organisms, and it is used in the production of amino acids, proteins, and nucleic acids. Molecular nitrogen is the most abundant gas in the atmosphere. However, only a few single-cell organisms are able to utilize this nitrogen form directly. The nitrogen cycle is largely dependent on microbial processes. Bacteria fix nitrogen from the atmosphere in the form of ammonia and convert the ammonia to nitrate. Humans have disturbed the nitrogen cycle in recent history by activities involving increased fixation of nitrogen. Most of this increased nitrogen fixation results from the commercial production of fertilizers and the increased burning of fuels, which converts molecular nitrogen to nitric oxide. Phosphorus cycle. Phosphorus in Earth's systems is usually in the form of phosphate. In living organisms, it is an essential constituent of cell membranes, nucleic acids, and ATP, which is the carrier of energy for all life forms. It is also a component of bone and teeth in humans and animals. The phosphorus cycle is relatively simple compared to the other cycles of matter, as fewer reservoir and processes are involved. Phosphorus is not a nominal constituent of the atmosphere, existing there only in dust particles. Most of phosphorus occurs in crustal rocks or in ocean sediments. When phosphate-bearing rock is withered, the phosphate is dissolved and ends up in rivers, lakes, and soils. Plants take up phosphate from the soil, while animals ingest phosphorus by eating plants or plant-eating animals. Phosphate is returned to the soil via the decomposition of animal waste or plant and animal materials. This cycle repeats itself again and again.
Yeah.